So welcome to 4Ks College online seminars. So we are launching online seminars where you can participate as a group of students, as a teacher, as a facilitator. So here is how we'll be going about it. We'll give you a QR code or a link that you can use to join one of our groups. So that's an example of a group already running. So we are seeing in these times of technology, it's not necessary for you to travel, for you to hire someone who has to travel just to come and stand in front of you and make a presentation. It's not necessary. You can do it from wherever you are. So you can simply connect your phone to a projector or a smart TV and beam this chat where you can type in your questions, where you can make an audio and interact with others. So the good thing about these online seminars is that you also get to know what other students, other facilitators are struggling to understand. You also get to know the common questions, and we'll be looking at past exam papers. So you can simply scan the code, like I said. You can inbox me so that I can add you to the group. For now, it's all for free. So grab this opportunity, tell a friend to tell a friend, and I'll meet you in the groups. So here's an example of a question that has been raised in one of our groups where there is need for an explanation when it comes to the variable oxidation states of transition elements. So it's one of the properties of transition elements that they form variable oxidation states. So I've put here an energy profile diagram, a graph showing the ionization energies of a group 2 element magnesium. So you can see that we have jumps. So when you remove your first 2 electrons, you jump into an energy level that is closer to the nucleus. So if you look at the SPDF notation there, you see that when you remove your first 2 s electrons, you jump into another energy level which is closer to the nucleus, and hence there is a higher energy requirement for you to remove electrons. And as you remove your next 1, 2, 3, 4, 5, 6, 7, 8 electrons, these are going to be at the same energy level, but of course you see some small increments every time you remove an electron. This is due to an increase in effective nuclear charge. So if every time you remove an electron, the effective nuclear charge increases, and hence the next electron is going to be slightly difficult to remove because of this increased effective nuclear charge. So that explains those small differences. I'm looking at those 8 electrons. After the 8th electron, you are going to have a big jump. This is because you would have moved now into an energy level that is even closer to the nucleus, which is the 1s. So this is the case with your normal metals, but when it comes to transition elements, you see that we do not see those huge jumps. This is because when we're removing electrons, our first electrons are going to come from the 4s and the 3d. So you realize that these 2 energy levels are very close to each other. Let's look at a specific example. If you look at vanadium, that's the outer shell configuration, 3d3, 4s2. So for you to remove those 5 electrons, the first 2 from an s and the last 3 from the d there, you do not require a lot of energy. They are all at relatively the same energy level, and hence this is what enables these transition elements to have variable oxidation states. It's because the amount of energy required to remove these electrons does not differ greatly. So vanadium here can have a charge of +5, +1, all the way to +5, because those 4s and 3d subshells are at relatively the same energy level. So Join our groups so that we discuss more. We'll be making instant videos. When you ask a question, you get a video instantly which you can download and share with your class and beam on your projector to show the rest of the students. So meet you in our seminar groups.